What you see is shaped by air molecule impact during supersonic flight of the aircraft. Layers of distinct shock waves. They represent the ghost of the Cold War in the sky. Classic design, teardrop airfoil gives strong lift at subsonic speeds. At 370 degrees from 3 Mach flight, 90% of the entire fuselage structure is constructed from a material known as B-120. However, once the speeds begin to approach the sound barrier, turbulence forms at the leading edge of the wings, triggering the phenomenon of sonic boom. The Blackbird used variable geometry wings. Unlike the triangular wing configuration of the 17, coupled with a 60-degree sweep angle design, this seamlessly connects the wing to the fuselage, keeping the shock waves within a bounded area, reducing wave drag by 70%. All supersonic jets feature large rear hexagonal designs. Even more astonishing is the extreme design on both sides of the fuselage. Slim, sharp edges capable of inducing controllable vortices at high speeds, not only providing an additional 20% lift through low-pressure effects, but also significantly enhancing the stability during flight to better cope with thin atmosphere at 20,000 meters of altitude. Titanium alloy cast, a unique material from Soviet scams during the Cold War. The engines developed by Pratt & Whitney are J58 variable cycle engines. This 32-ton power system perfectly combines turbojet, combines high strength with excellent thermal stability. The fuselage cross-section employs a flattened design, coupled with a 5-degree radar wave deflection angle on the edges, thus reducing the radar cross-section area. To the level of a small business jet, this stealth concept from the 1960s still serves as the benchmark for modern fighter aircraft. The most remarkable component of the Blackbird reconnaissance aircraft is this once thundering and scramjet engine characteristics. Ejecting the special GP7 aviation fuel with combustion temperatures reaching 140 degrees Celsius. This 32-ton power system perfectly integrates turbojets, with a cone-shaped intake at the front to control shockwave patterns, bringing intake speeds of 32 Mach down to supersonic through 5 shockwave reflections. The combustion chamber employs layered injection technology, using an outer nozzle to inject compressed air into the fuel pipe, which also serves as the coolant for the fuselage heat pipe system. It expels the special GP7 aviation kerosene, a fuel that burns at 140 degrees Celsius. When all 6 afterburning combustion chambers are fully open, a single engine can generate 15 tons of thrust. Combined with converging and diverging, the secondary acceleration of the nozzle allows exhaust to reach 3 Mach speed. The specially designed bypass system can also adjust the Mach intake airflow by 40% automatically, ensuring optimal arch frame from sea level to 25,929 meters in altitude. This clever design allows the Blackbird to achieve 58% of thrust at 240,000 meters, entirely from intake compression, free of charge, ultimately creating a speed myth of 309 kilometers per hour. Furthermore, besides the narrow cockpit, most of the Blackbird's fuselage serves as a fuel tank. Capable of carrying up to 46,000 liters of fuel at 33 Mach at maximum flight speed, fuel consumption can even exceed 95 tons per hour. As a strategic reconnaissance platform, the second waste drone can cover 280,000 square km in 20 minutes. Optical resolution is 0.3 m, sufficient to identify most ground vehicle types. Its mission profile frequently accelerates at a velocity of 3 Mach, slowing to 2.5 Mach in the target area. For taking stunning oblique photography, the entire process requires not even entering enemy airspace. It's also unarmed throughout its extensive and remarkable 32 years of dedicated service, successfully completed over 4,000 missions in various operations, encountering over 4,000 surface-to-air missiles, yet maintaining a 0 interception record. Noting this performance stems not only from its performance advantages, but also from its unique speed. Defensive tactics: when radar locks on and alarms echo loudly throughout the vicinity, the pilot simply pushes the throttle. First aircraft in history to achieve sustained 3 times the speed of sound. Though it is a product of the 1960s, its innovative and forward-thinking design, combined with sophisticated and complex technology, continue to shine brightly and illuminate the world around you with your radiant light, with the brilliance of human engineering wisdom. In 1998, the last Blackbird was retired, but of the 85 flight records it set, to this very day, a total of 23 instances remain unbroken, making it a true milestone in human flight history.